Hi students, welcome to this course, PLC Automation, an introduction to Programmable Logic Controller, PID Tuning. The keywords, PID Tuning, the system mode, open loop transition response, ultimate cycle, frequency response, fine-tune, the body diaphragm, the optimal control settings, the process lag and the process rate, the minimum controller gain, the period of oscillation, a variable frequency disturbance, PID tuning. PID tuning refers to the adjustment of the system's mode. Such tuning must be done online. That is, while the process is running. 3 tuning methods are involved: open loop transition response, ultimate cycle, and the frequency response. Essentially, the initial settings of the control system are estimated, and then the 3 modes are fine-tuned, the purpose of which is to reach the optimal control settings. In the open loop method, control parameters are determined while the system is in the manual mode of operation. First, the process control loop is opened so that no feedback occurs. Second, the tuning is begun by operating the process on manual control until the major variable stays constant. Third, a step change in manipulation device is introduced, and the response of the control variable is recorded. Fourth, the controlled variable responds to the manipulated variable change. As a result, parameters used in tuning equations are determined. Finally, the resulting parameters will include the process lag and the process rate. With the ultimate cycle method, a loop is adjusted until steady oscillations occur. 2 measurements obtained from this method are known as the minimum control gain and the period of the oscillation. The former is the amount of gain required to cause the system to oscillate. The latter, also known as the ultimate period, represents the period of this oscillation. In the frequency response method, body parts are used to obtain a straight line approximation of the magnitude and the phase angle represent to frequency. The body plot is obtained by opening the loop and providing a variable frequency disturbance of the controlling variable. Type of PID functions. The keywords: loop control, loop identifying number, update time, the deadband value, a worksheet, a preset value. Figure 23.8 is a representative loop control of PID function. A loop identifying number is specified in the block. Update time in the block is also specified. The time in seconds, for example 15 seconds, is the interval controlling the update procedure frequency. Coil P goes on when the function is enabled. Coil Q goes on when the update time is reached for 1 second. This picture shows typical loop control functions. A typical PID function of intermediate complexity is shown in figure 23.9. Some PLC combine the previous shown loop control functions with the PID function. This example is for the PID function alone. This picture shows typical PID functions: enable, auto or manual, hold. PID number, input, output, set point, arrow, P gain, I gain, G gain, and deadband. The functions of the input, output, and the functional descriptions are input, enable, the usual function enable line, manual and auto, manual or automatic mode, hold, used for clamping or for logic transition control, output, P, the coil number assigned, Q, an output limit coil used in the logic. Functional description and the values. PID numbers, the PID block identification number. Input, the register in which the process variable is stored. Output, the register in which the output algorithm is stored. Set point, the register in which the set point is stored. Arrow, the register in which the value of arrow equal set point minus input is stored. dB, the register for deadband value. Change maximum, the register in which the maximum allowable rate of change is stored. P gain, the register in which proportional gain is stored. I gain, the register in which the integral term is stored. D gain, the register in which the derivative terms is stored. Most of the functions in a block are written as percentage of the set point. The block value may be programmed as constant or moved in from other register. dB, deadband, is effectively the tolerance you can live with for the process in percent. The last three functional block inputs are adjusted for tuning the system in cooperation for optimal process control. A more complex PID function is shown in figure 23.10. A worksheet instruction set for this function is shown in figure 23.11. The PID function is designated loop control in this format. This function, when properly enabled by input contact, performs PID analysis and control. This picture shows the PID PLC function. This picture shows PID PLC instruction set. Typical PID functions. The enable function compares the set point with the process variable. If they differ by more than a preset value, an appropriate correcting signal is sent from the function output to the controlling device controller. The input parameters are put into 32 consecutive registers, ending with the register specified as loop table N. The number of registers required will vary by model and manufacturer. On the worksheet, not all register functions are used for all processes. Key registers are 13 through 16 for system. Tuning 27 and 28 for set point and allowable variance. And 29 and 30 for time set. Register 20 is for configuration word, as specified in detail in the lower table. Homework. Handwriting all keywords and submitting them to Coach Facebook. Just do the online quiz and see you next time.